Hello everyone, I am your friend Shadab Imam, and today we are going to find out the critical path of a given network problem. And in order to do so, we must understand what is critical path and how to find a critical path using a critical path method. So let us see here. Critical path is the chain of activities with longest time durations. These activities are called critical activities. They are critical in the sense that delay in any of them results in the delay of the completion of the project. So from this we can conclude that the critical path is actually a path with the longest time duration, and when a critical activity, that is all the activities that constitute a critical path are known as critical activities, and if any of the critical activities is delayed, then the whole project is delayed by that particular time. And now let us see what are the steps we need to have to find out the critical path. So first is to calculate the time schedule for each activity. Now it involves the determination of time by which an activity must begin or completed. That is, we need to determine here the earliest and the latest times. Now the second step is to calculate the time schedule for the completion of the entire project. Now in this step it involves the calculation of the project completion time. And finally step 3, to identify the critical activities and find the critical path. So let us begin here. So let us see what our question says. Task A, B, C, D up to HI constitutes a project. The precedence relationship R. So precedence has been given in this form, and we first need to convert it into tabular form to draw the network diagram. Now it says that we need to draw a network diagram to represent the project and find the critical path when the time in days of each task is as follows. So the time in days for each activity has been given. So to draw the network, we need to first find the precedence in a tabular form. So I have already drawn a table here, and we need to find the precedence here. So let us see. We have already discussed that if it has been written as A greater than D, this means that activity D, this is activity D, and this activity is preceded by activity A. So it is preceded by this activity A. So from this we need to convert this into tabular form. So let us see here. It says that D is preceded by A. So activity D is preceded by A here. Now E is also preceded by A. So E is also preceded by A. Then F is preceded by B. So F is preceded by B. And F is also preceded by D. So F is also preceded by activity D here. Now G is preceded by C. So activity G is preceded by activity C here, and H is also preceded by activity C. So H is also preceded by activity C. I is preceded by F. So activity I is preceded by activity F here, and activity I is also preceded by activity G. So this is also preceded by activity C. Now we can see that there are 3 activities A, B and C where no precedence is given. So these are unpreceded activities A, B and C. So we have prepared the table to find out the precedence, and now let us construct the network diagram. So first of all we need to find out the unpreceded activities. So we can see here activity A, B and C are unpreceded activities. So we will start this from activity A. This is activity A, this is activity B, and this is activity C. Now activity D is preceded by activity A. So we will end this activity A here, and from this event we can see that activity D, this is activity D, and activity E is also preceded by activity A. So here activity D is also activity E is also preceded by activity A. Now activity F is preceded by B and D. So we can see that B and D are here, so we will converge these two into the single node. And now at this node activity D and B are completed, so we can start activity F from here. So activity F starts from this node. Now activity G is preceded by activity C. So G is preceded by C, so we will end activity C here, and activity G, this is activity G. And similarly activity H is also preceded by activity C only. So at this node activity C only is completed, so this is activity H. Now activity I is preceded by activity F and G. So this is F and G, we will convert this into the single node, and at this node activity F and G are completed, so we can start activity I from here. This is activity I. Now as all the activities are completed, we need to see which activities are still open. So E, H and I are open, so we will converge these activities to a single node here. So we will converge this into a single node, and this is the finishing or terminal node. So this is the network here we have prepared, and now we need to number these events. As we have studied, we will first give the initial node where all the arrows are outgoing arrows as 1. Now delete all the outgoing arrows. We will have 2 new initial event, so this will be 2, this will be 3. Now delete all the arrows from the numbered event. We will have this new initial event, so this will be 4. Similarly this is 5 and this is 6. Now to calculate the critical path, we have been given the time for each activity, so we will write here the time in bracket. Activity A is 8 days, B is 10, C is activity C is 8, activity D is 10, E is 16, F is 17, G is 18, H is 14, so here it is 14, and I is 9. So these are the time given for corresponding activities. Now we have drawn the network. We need to calculate the earliest and the latest time. So how can we calculate? So first we will do is we will calculate the earliest time. So to calculate the earliest time, we will use the forward pass method. Now what is forward pass method? We will start from the starting node, and as we go on to the other node, we will add the time of that particular activity, and if there are more than one node, we will select the maximum time duration that is coming at that particular node. So this is the forward pass, and later we will calculate the latest values by using backward pass. So let us start here. To calculate the forward pass, we will see that at node A time is 0, so E1 is equals to 0. Now moving on to node 2, we can see that there is only one activity coming at this node, so this is 0 plus 8, so earliest time here for E2 is 8. Similarly we will calculate the earliest time for 3, So E3 here. Now we can see that there is only one incoming arrow at this point of time. So this is 0 and this is 8. So 0 plus 8 is 8. Now moving on to 4. At node 4 we can see that there are two arrows coming. So we will see that timing at this particular node, the time is 8 and 8 plus 10 is 18. And if we are coming through activity B, this is 0, 0 plus 10 is 10. So we will select here the maximum value. So as we can see that this is 8 plus 10 is 18. So we will select the value 18 here. E4 is equals to 18. Now moving on to 5, we can see that there are two arrows coming in. So this is 18, 18 plus 17 is 35, and this is 8, 8 plus 18 is 26. So we will select the maximum here. So this E5 will be 35. Now as we can see, for the final node there are three arrows coming. So for this arrows, this is 5 plus 9 is 44. This is 8 plus 16 is 26, and here 8 plus 14 is 22. So we can see that the maximum value here is 35 plus 9, 44. So E6 is 44 days, and this shows that this is the completion time of the project. Now in order to calculate the latest time, we will use the backward pass method, and in using backward pass method we will take this completion value as the value of L6, that is 44 days, and we are going to reduce this as we go from one activity to another. Suppose we are coming from 6 to 5, we can see that there is only one outgoing activity. So we will decrease from 44, we will decrease 9. Similarly, we can see that if we go from this route, we will select the minimum value among these two outgoing arrows. So let us see here. So this initial we will take is equal to 44, because we do not want any more delay, or we need to complete our task within this specified completion time. So let us see here, moving on to from 6 to 5, this is 44. 44 minus 9 is 35. So L5, that is latest value at node 5, is 35. Now moving on to 4, we can see that only one outgoing arrow is here. So this is 35. This is 35. 35 minus 17 is 18. So L4 is coming as 18. Now moving on to node 3. At node 3 we can see that there are two outgoing arrows. Okay, so what we will do is we will select this 35 minus 18. So 35 minus 18 is 17. And here we have 44. 44 minus 14. So 44 minus 14 is 30. So this is 17, and from this it is 30. So here for the latest value we will select the minimum value. So we will select the 17 here. So L3 here, L3 is equal to 17. Now at node 2 we can see that there are two outgoing arrows. So for first arrow it is 44 minus 16. So this is 28, and from here this node is 18. 18 minus 10 is 8. So we will select the minimum value here. So we will select L2 as 8. Now moving on to 1, and this will come as L1 equal to 0. So this will be 8 minus 8 is 0. We will take the minimum value here. Now as we have calculated all the earliest and the latest value at each node, what we will do is we will see at which node the value of E and L are equal. So we can see that at this particular node 1 they are equal, at node 2 they are equal, at node 3 they are not equal, at node 4 they are equal, at node 5 they are equal, and at node 6 they are equal. So from these nodes we will draw another line to show that this is the critical path. So from 1 to 2, then 2 to 4, then 4 to 5, and 5 to 6. So here in this network our critical path is 1, 2, 4, 5 and 6. So the critical path here is equal to 1, 2, 4, 5 and 6, or it can also be represented in the form of activities. So activity A, D, F and I. So it can also be represented as activity A, D, activity F and activity I. So this is our critical path, and the value of critical path, that is the project completion time, is coming as 44 days. So this is equal to 44 days. Okay, so we have drawn the network diagram here. Okay, we will find the critical path, and now let me again show you how we have find earliest and the latest times here. So for earliest time, to calculate the earliest time, we will use forward pass, and in this forward pass we will select the maximum value. So for calculating the earliest times, we will select the forward pass, that is we will start from the starting node, and as we progress we will finally reach the terminal node. And in this forward pass we will select the maximum value. That means if at any particular node there are more than one arrows are coming, suppose at this particular node there are 2 arrows are coming, so among these 2 arrows we will select the value which is maximum. And to calculate the latest values, to calculate the latest times, we will use the backward pass. And in this backward pass we will select the minimum value. So in order to calculate the latest time, we will start with backward pass. That means we will start from final activity, final node or terminal node, and we will take this initial project completion time as the final value of L6. Then we will reduce this. So as we can see that there are 3 arrows from here, so we can see this, we can subtract this for different activities and see what is the value of L is coming. And if there are more than one arrow coming, as suppose in this case for this particular node, we can see that from here there are more than one arrow going out. So what we will do is we will select the minimum value here. As we can see, this is 35 minus 18 is 17, and from here this is 44 minus 14 is 30. So we will select the minimum. We have selected the minimum value here, that is 17. So please keep in mind these 2 things, that is to calculate the earliest time we will use forward pass method, in which we will select the maximum value, and to calculate the latest times we will use the backward pass method and we will take the minimum value here. So I hope you like this lecture. In the coming lecture we will see how to calculate the float and what are the different types of floats. So if you like this lecture, please share the lecture. Have a nice day. Thank you.